Hey students, this is lesson 5.7, inequalities in two triangles. We're going to learn the inequality theorem of triangles here and learn how to apply that to problems. Go ahead and do this review. Notice that I added this up in the corner. You might want to write that down. You're going to need that to do the review, this part right here. That's the property, the comparison property of inequalities. Go ahead and do that and I'll check back with you. All right, so here's the big theorems. They're called the hinge theorem and the converse of the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. So the triangle with the longer, the bigger angle has the longer third side. And also, if the third sides are not congruent, then the larger included angle is opposite of the third side. And that part is considered the converse. This one is the converse. This one is the hinge theorem. I think we're going to use hinge theorem, not the nickname is the side angle side inequality. I don't really like that so much, so we're going to use that. But go ahead and do 13 and 14 here using that theorem. I'll check back with you. All right, problem one, we're going to use the hinge theorem here. Which of the following statements must be true? So what we have here is we have that side congruent to this side congruent to this side, and then we have, if we look at these included angles, we see that the angle in triangle ABC here is greater than the angle in triangle RST. So by the hinge theorem, that tells us that this side has to be greater than this side. So we're going to choose D. AC is greater than RT. And our justification is the hinge theorem. All right, you try that. Here's another problem where we can use the hinge theorem, assuming that these two cheerleaders here are identical twins. And their arms are the same lengths. We can say that, so this would be, and each arm is the same length, we could say that all those are congruent. So by the hinge theorem, the cheerleader with the greatest angle should have their hands the furthest apart. So we're going to say cheerleader B has her hands further apart by the hinge theorem. All right, and next problem. We're going to use the converse of the hinge theorem here. We want to know the range of possible values for x. Figure that out. I think we have to assume that this angle right here is acute, and it definitely looks like an acute triangle, so we can assume that angle is acute. And so we're going to start by saying the measure of angle A is less than the measure of angle D. And that is by the converse of the hinge theorem. And since this line here looks shorter than this line here, we must have that being true. And if that's true, then we also have that 4x minus 8 by substituting is less than 90 using those angles. And actually we could say an acute angle is actually between 0 and 90. So I'm going to put that right there. And I can say that here also. because we know that that angle has to be greater than 0. So, and so this is the converse of the inverse theorem here. And this is by substitution. And we can say that adding 8 to each of these, we get 8 is less than 4x is less than 98. And that's the addition property of equality. And then we can say that divide everything by 4, we can say that 2 is less than, x is less than 98 divided by 4 is 24.5. And that's the division property of equality. And so we have our answer, x must be between 2 and 24.5. All right, you try that. Hey, before I go on that, I think we made some assumptions there that we really shouldn't have to. I think that these should have been labeled 10 and 8 to make it make more sense. So we absolutely know that the length of the longer side of the one is greater than the length of the other, to use the converse of the inverse there. All right, let's prove a relationship in the triangle using these new theorems. So we have here the measure of angle RUS is 100, and we also have that SU is equal to UT. And we're going to prove that RT is less than RS. So I'm going to start just by saying this: the measure of angle RUS equals 100. That's given. And we also are given that SU is equal to UT. And we know that if we add these two angles up, measure of angle RUS plus the measure of angle RUT, that'll equal 180. And that's by definition of a linear pair, or the linear pair postulate is. I'm going to say linear pair. And then we can just substitute 100 for the measure of angle RUS, so we get 100 plus the measure of angle RUT is equal to 180, and subtracting 100 from both sides, we get the measure of angle RUT equals 80. And my reason for that is substitution and subtraction, property of equality. Okay, now that we have the measure of angle RUT equals 80, we also know that RU is equal to RU. And that's reflexive property of equality. So we can now say that, a little more room here, we can now say that RT is less than RS, and that is by, let's add a little bit here, just so we don't miss out on this. We know that the measure of RUT equals 80, so we can now say that the measure of angle RUT is less than the measure of angle RUS, and that's by, let's just say that's the definition of less than, because obviously 80 is less than 100. Okay, and since we have that as less, we have RT is less than RS by the hinge theorem. All right, go ahead and fill in the reasons for this proof. All right, that's it for the lesson. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.